Hello everyone and a very good evening. So before we start this session, first let me know if I'm perfectly visible and audible to you or not. Yes, quickly you can write in the comment section below and I'll understand. Alright, so we have Pratyush Bajpai. Anshika is here. Yes. Manimala. Nitya Modi. Yes. Anshita, Saranteja, Sanya, Yashad Kesarvani is giving a lots of thumbs up. Rav Computex, Navdeep Singh, DIY Crafts, yes. Anjali is here. Alright. So there is no glitch at all, so we can continue. My name is Khushbu and welcome to yet another wonderful session. So as you would have seen the title of the video, today's session is on properties of quadrilaterals. Well, the sessions on quadrilaterals has been divided into two parts. So today we'll be discussing the part 2 of quadrilaterals. And after this session is over, you all know that we are going to have a live quiz. So excited for that? Yes. Pranavi, Akriti, Sudhir, Astha. Yes. Yashat is giving a lots of thumbs up. Rachit. Lakshmi is here. Pranavi. Saranteja says yes. YV studies. Nitya Modi. Sanya. Yay. Menti. Yeah? Alright. So before we start this session, let's first take a look at all the contents that we are going to discuss today. So we'll be discussing the properties of quadrilaterals, then we'll have a quick discussion on another condition for a quadrilateral to be a parallelogram, and at the end we are going to discuss the midpoint theorem and we'll be discussing a few questions related to this as well in between. Alright, so let's start off with our first topic, that is properties of quadrilaterals. So we discussed the properties of quadrilateral in the previous session also, right? So in the first session we proved a theorem that in a parallelogram opposite sides are equal, right? Now let's see the converse of this theorem. Right? So Converse says that if in a quadrilateral each pair of opposite sides is equal, then we can call it a parallelogram. Right? Now to understand this, let's visualize it. So let's consider this line segment AB. And let's take another line segment CD, and what we see that AB and CD are two equal and opposite sides. Right? Now let's take another line segment of any length and inclination, and we see that both this BC and AD are equal and opposite sides, and this can be used to create a parallelogram which can be used to create a quadrilateral, which is actually a parallelogram we can see, right? Yes, Suraj is here. We have Lakshya Gupta. Astha, Byjus is the best, amazing. Thanks for your support. Thank you, Astha. Alright, so that's how we can create a parallelogram from a quadrilateral, right? So we can say that when each pair of opposite sides is equal, we can call that quadrilateral a parallelogram. Alright. Now we have discussed another theorem in the previous session that in a parallelogram, opposite sides are equal, opposite angles are equal. We all know that. Now let's see the converse of this. Converse says that if in a quadrilateral, each pair of opposite angles is equal, then we can call it a parallelogram, right? So let's visualize this. So we can see that we have a quadrilateral here, quadrilateral ABCD, and here we can see that the opposite angles, angle B and angle D is not equal. Angle A and angle C is also not equal, right? But now you can see if angle B and D becomes equal, then this quadrilateral actually becomes a parallelogram, right? Hence, we can prove this, that when opposite angles of a quadrilateral are equal, then you can call that a parallelogram. Nibha Chaudhary, you are my favorite, ma'am. Thank you. Yes. Alright. So is this clear to all of you? Both the properties, like how we can use the converse of these theorems. Yes? Yes. Bishal, I got all the topic clear. Yes. Pratyush, B for brilliant, B for Byjus. Thank you. Bishal says yes. Raghav says yes. DIY crafts, Byjus rocks. Thank you. Alright. So let's take a look at another property. So we learned this theorem last time that diagonals of a parallelogram bisect each other, right? Now let's see the converse of this. So if the diagonals of a quadrilateral bisect each other, then we can say that it is a parallelogram, right? Now to understand this better, let's visualize it. So what do we see here? Let's consider two lines, which are the diagonals of a quadrilateral. Now let's plot the midpoints on both the lines. Now we will overlap these two midpoints without taking care of the orientation of the lines here. Now we will join the endpoints of these lines, and what do we see here? We see that this quadrilateral actually becomes a parallelogram, right? So we can say that when diagonals of a quadrilateral bisect each other, then we can call it a parallelogram. Vishal, your way of explanation is excellent. Thank you. Yes. Anchita, 7, 8, Byjus is great. Thank you, Anchita. Yes. Alright, so here we saw that how a quadrilateral can be converted into a parallelogram, right? Now let's try out a few questions to understand this better. Show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus, right? Question already specifies that diagonals of a quadrilateral are bisecting each other, right? We just learned a theorem, so we will use that to understand this. So diagonals are bisecting each other at right angles. This is also mentioned. Now we need to prove it a rhombus. Okay. So let's visualize it first. Let's draw any two lines, right? And now let's plot the midpoints on it like this. Now we will overlap them in such a way so that these lines are perpendicular to each other, right? You can see that these lines are perpendicular here. Yes. Yes. Someone says Astha has a question. Yes, Astha, what do you want to ask? Alright, so these diagonals, you can see that these two lines are perpendicular to each other. Now as I discussed in the previous theorem, if you remember, we joined the endpoints of these lines. So here also I'll be joining the endpoints of lines, these lines AC and BD, right? So what do we get at the end? We get a parallelogram. This is what we learned in the previous theorem, right? That we discussed. Now question says we have to prove it a rhombus, right? So here the diagonals are already bisecting each other at right angles. So this is one of the properties of rhombus. Now to prove it a rhombus, I'll have to prove that all the sides are equal. It is a parallelogram, that means opposite sides are equal, but we need to prove all the sides are equal. So let's analyze this further. So what I'll do here is, since AC and BD are the perpendicular bisectors here, this implies that this OA and OC, this will be equal, and this OB and OD will also be equal. These are perpendicular bisectors, so these angles, all these angles here, angle AOB, angle BOC, angle COD, angle AOD, they all will be 90 degrees. Yes. Navdeep Singh, Byjus is amazing. Thank you. Yes. Alright. So here all these angles are 90 degrees. This is the given information that we get from here. Now, triangle OAD, that you can see the highlighted triangles over here, triangle OAD and triangle OCB, these will be congruent, right? We can prove them congruent. And this triangle OAB and triangle OCD, they will also be congruent using the SAS congruency criteria, right? We can prove them congruent because we have the given information to prove them. So since triangles are congruent, their corresponding paths will be equal, CPCT, right? So I can say that AD and BC will be equal, this AD and this BC. This will be equal, let me mark it here, AD and BC will be equal, and this AB and CD will be equal, right? Similarly, these two triangles, triangle OAD and this triangle OCD, they are also congruent, right? The highlighted ones. Alright, so then these are also congruent, and this triangle OAB and triangle OCB is congruent. I can say that AD and CD, this AD and this CD will be equal, and AB and CB will also be equal. So you see AD is equal to BC also, AD is equal to CD also, AB is equal to CD also, it's equal to BC also. That means all the sides over here are going to be equal, right? Since all sides are equal, I can call this a rhombus. Yes, that's how we can prove it. Yes, we have to make equal, the adjacent sides have to be made equal here. Ayush Biswas, Byjus makes the world easier. Thank you. Parvati, Byjus is the best learning platform in India. Thank you. Yes. So is this clear to all of you how to prove this? See, we have seen the visualization also, and you have seen how you can prove it using the theorems, using the properties and all. Yes. Nibha Chaudhary, I'm traveling but still taking your class because your classes are amazing. Thank you, Nibha. Yes, alright. Let's take a look at another question. Show that the diagonals of a parallelogram bisect each other. What is the given information here? We are talking about the diagonals of a parallelogram. So we are only given that It is a parallelogram, right? We need to show that the diagonals here are bisecting each other. Bisecting means they're dividing them into equal halves. Yes? Alright, so we have a parallelogram here, ABCD, and AC and BD are the two diagonals. They are intersecting at this point over here. Alright, so this is parallel. This is a parallelogram. That means AB is parallel to CD. This AB and CD are parallel, and this BC and AD are also parallel. This is the given information. So whenever you read such questions, always first draw the figure, write down the information that you get from the question. Then write down what you need to prove, and then what all things you require to prove that. Yes. So in this triangle OAB and triangle OCD, these two triangles, right, we can say that these two angles will be equal. Why? These two lines are parallel. And this is nothing, it is acting as a transversal here. So a Z is formed, you see. So these angles are what? These are alternate interior angles. They will be equal, right? Now here, this triangle. If you see in these triangles, these lines are also parallel and this is a transversal. So again a Z is formed here. You can see the angles are highlighted in blue. So this angle BOA and angle ODC will also be equal. Again, alternate interior angles are formed, right? We need another thing as well, because we need three things to prove them congruent, right? So this AB and CD are also equal. Why? Because the opposite sides of a parallelogram are equal. So what we see here is that the triangle OAB and triangle OCD will be congruent using the SAS congruency criteria. Now since triangles are congruent, I can say that this OB would be equals to OD, right? Corresponding parts of congruent triangles will be equal, and this OA and OC are also going to be equal. So we can say that AC and BD actually bisect each other. Yes. Yes, Manimala, ASA. Yes, ASA congruency rule. Yes. Yes. Alright, so is this clear to all of you how to prove how to show that the diagonals of a parallelogram are bisecting each other, right? Prince Rajput, angle ADB and angle CBD are also alternate interior angle. ABD. This angle ABD and which angle? CBD. CBD. No, we cannot call them alternate interior angles. Whenever alternate interior angles are formed, make sure that the lines are parallel, they are intersected by a transversal, and a Z will be formed, right? You will see a Z forming there. Then only you can say that alternate interior angles are equal. Ayush, yes ma'am. Nibha Chaudhary, clear ma'am. DIY Crafts, clear. Anjali, clear. Parantak Singh, yes ma'am. Sushmita, yes, clear. Great. Alright. So this was about the properties of quadrilateral. Now let's move ahead. Let's see what do we have next. So our next topic is about another condition for a quadrilateral to be a parallelogram. Alright. So we learned this theorem, right? A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel, right? This is what we have learned. Astha Singh, you want me to explain that again? Alright, let's take a look at that one more time. So here we have this parallelogram. This was the only given information in the question. That means the sides, opposite sides are parallel. They will be equal also, right? So we considered these two triangles, OAB, this triangle. Let me just highlight it one more time. This triangle and this triangle. So you can say that the opposite sides of a parallelogram are equal. These two sides are equal. This will be alternate interior angles, these two. And this will also form alternate interior angles. So three things you have already got. You can say that the triangles are congruent. So when triangles are congruent, their corresponding parts are equal. So I can say that this OB and OD are equal, this OA and OC are equal. That means they are bisecting each other, right? Dividing them into equal halves. Yes. Alright. So I hope this is clear now, Astha. Yes. Yes, yes, yes. DIY Craft says yes, ma'am. Alright. Alright, let's move ahead. So now, as I said, I'll be discussing another topic, another condition for a quadrilateral to be a parallelogram. So we already learned this theorem that a quadrilateral is a parallelogram if opposite sides is equal and parallel. This is what we learned today, right? Now let's visualize it to understand it better. So let's consider this quadrilateral ABCD over here. So for the pair of opposite sides AB and CD, right? For these two, right? First, what we will do? Let's equalize their length. AB and CD are now equal. Now let's make them parallel. So once we make them parallel, what do we see? That we get the parallelogram ABCD by just adjusting the opposite sides of the parallelogram. Yes, Papiya Das says clear. Yes. Yes, yes, yes. Soumya Verma, yes ma'am, my doubt is cleared. All right. Yes, Shobna, I love your teaching, ma'am. Thank you. Gaming Guru, clear. DIY crafts, crystal clear. Yes. All right. Now let's take a look at the another topic. So next we have the midpoint theorem, right? So it's a very important topic from the exam point of view, I would say. Yes. So let's first understand this. So we have a triangle here, right? This triangle ABC. Now what we'll do is we will mark the midpoints M and N on the two sides over here, on AC and BC. So these are the midpoints. That means they are dividing these sides into exactly two equal halves, right? So we have joined this MN over here. Now we'll extend this MN and we'll draw a line through B which is parallel to AC such that it is meeting the another line which is drawn through M at this point D over here, right? You can see that they are meeting at this point D. Yes. A parallelogram is always a rhombus? No, it's not like that. A parallelogram, you cannot say it is always a rhombus, right? You will have to prove it if some things are given over there, right? You cannot call a parallelogram a rhombus. But yes, a rhombus is always a parallelogram. The converse is true. All right. So, to prove this, what we'll do here, first of all, we will prove these two triangles congruent. This triangle MNC and this triangle BND. We can prove them congruent using the ASA rule, angle side angle rule, right? Because these vertically opposite angles are going to be equal. We just said by construction that these lines are parallel. So we can say that again alternate interior angles are formed. These will be equal over here. These angles are equal and again this N is the midpoint, so this is going to be equal. So by ASA, angle side angle congruency rule, we can prove them congruent. Yes, so these triangles are congruent now, right, by ASA rule. So when triangles are congruent, we know that their corresponding paths are equal. So we know one thing, that already M is the midpoint. So AM and MC are equal over here, right? Yes. Rachit, you want me to repeat that again? All right. So here, what we see that we have a triangle. So we have these two midpoints. We joined them. We drew a line from here through B such that it is parallel to AC and these two are meeting over here. Then you prove these two triangles congruent, right, by angle side angle congruency criteria. So once you prove them congruent, their corresponding paths are going to be equal, right? So we already know that M is the midpoint of AC, so AM and MC are going to be equal. Since these triangles are congruent, so this MC and BD are going to be equal, so all three of them would be equal. Also this MN and ND would be equal, right? Again by CPCT. Anshita, yes, we will have Menti today. Sanya, ma'am, please do chapter circle after this because I find this chapter very difficult. Don't worry, Sanya, we'll be covering all the chapters that are a part of your syllabus. Don't worry about that. Manimala, the line from the midpoint to the midpoint on the other side and the line is parallel to the line is half of it. Yes, that's the midpoint theorem, right? All right. So here we have proved that these sides are going to be equal, right? So understand this thing. Now we already from construction we said that this AC and BD are parallel. So if AC and BD are parallel, so a part of AC, that means this AM and BD will also be parallel, and AM and BD are equal also. So when one pair is equal as well as parallel, then we can call it a parallelogram. If one pair of sides in a quadrilateral is equal as well as parallel, then we can call that a parallelogram. That means ABDM is a parallelogram. I think just a few minutes before somebody asked the same question in the comment section, right? That can we call a quadrilateral a parallelogram if we see that the sides are equal as well as parallel? Yes, so that's going to, so ABDM is a parallelogram in this case, right? So since it's a parallelogram, that means the opposite sides are going to be parallel now, right? The other pair will also be parallel. So I can say that this MD and AB will also be equal. That means a part of MD, which is MN over here, that will also be parallel to AB. So MN is parallel to AB. Quadrilateral sum is 360 degree. We did that in the previous section, Pratyush. You can watch that. You can watch the concept capsule of the previous session that we did on quadrilaterals. Sum of alternate and opposite angles, Yashasvi. See Yashasvi, there is no specific rule for that, sum of alternate and opposite angles. Yes. Alright. So now this is parallel. So we already learned many properties of triangles as well as quadrilaterals, right? Now let's study yet another result which is related to the midpoint of the sides of the triangle. So we have a theorem which says that the midpoint theorem, the line segment joining the midpoints of two sides of a triangle is parallel to the third side, right? And is half of it. So let's see the visual proof. So we have a triangle over here, right? Triangle ABC. Now we'll plot the midpoints of any two sides, let's say AC and BC over here, and we join this MN. Right? Once I join it, what do we see here is that we see that this MN is parallel to AB, right? So this is what we were supposed to prove here, that the line segment joining the midpoint of two sides of a triangle, so we join the midpoints of any two sides of the triangle, is parallel to the third side. You see it is parallel to the third side, right? This is what we were supposed to prove. Yes, Nibha, this is the second session. D. Deepak, absolutely. After this session, we will have Menti. Yes. All right. Now, let's try this magic one more time. So again, on the same triangle ABC, this time I'll plot the midpoints on this AB and BC. Let's mark them P and Q and let's join them. So what we see here is that this line PQ is parallel to AC, right? This is parallel to it. And this is what we were supposed to prove here, right? Now let's do this one more time. Again, this time I'll use another side. So we have the same triangle ABC. And this time I'll plot the midpoints on AC and AB over here, right? We have S and R. So once we join them, we see that it is parallel to BC. So whenever I'm joining the midpoints of any two sides of the triangle, I see that that joint line is parallel to the third side. And this is what midpoint theorem says. Yes. You want me to repeat again? See, let me just tell you the crux of this theorem. So let's suppose you have a triangle, right? I'm just telling you the crux, final result iska kya hai? You have a triangle. At any two sides, you draw the midpoints. Let's suppose I'm drawing here. I plot the midpoints here. Let's mark this as P and Q, right? You join them. So that joint line will definitely be parallel to the third side. This is what midpoint theorem says. And this joint line will be half of it. That means PQ will be half of AC also. You can join the point, you can plot the midpoints on any two sides, right? Join them, it will be parallel to the third side. Yes, is it clear? Yes, Lakshmi, I hope your doubt is clear now. Yes, thank you so much, ma'am. DY Crafts, okay, ma'am. All right, great. So let's move ahead. So the line drawn. So we are talking about another theorem now. Line drawn through the midpoint of one side of a triangle. So carefully understand this. This time I'm talking about the midpoint of one side of a triangle. Parallel to another side bisects the third side. First of all, what does this statement means here? So we have this triangle. Let's consider this triangle ABC, right? Line drawn through the midpoint of one side of a triangle. This time I'll plot the midpoint on just one side, right? So let's suppose I plot the midpoint here, right, on AC. Now draw a random line of any length, right? So what we'll do here, I'll place this line over here such that it intersects the midpoint M. Now, we move this line such that it is parallel to this AB because the statement says that parallel to another side. What is the another side? Another side is this AB, right? So it will bisect the third side. Third side over here means BC. You see, once we move it such that it is parallel to AB, then it bisects this BC. That means I can say that this BN and NC are now going to be equal. Saranteja, yes, this theorem is the converse of midpoint theorem. Himanshu Patma, yes, we will have Menti after this session. Yes, so this is the converse of midpoint theorem. So basically the crux is you have a triangle, right? You can draw the midpoint at any one side. Let's suppose I draw here, right? This is M. You draw any line from here. It should be parallel to this side, to the third side. Then it will definitely bisect the third side. This will become equal. Saranteja, yes. Special day, yes, clear. DIY crafts, lots of thumbs up. D Deepak, yes, converse of midpoint theorem. So I hope midpoint theorem and converse of midpoint theorem, that's crystal clear in your mind. You know the difference, right? D Deepak, yes, it is easy to prove. Bishal day, got it, ma'am. Ayush Solanki, yes. Papiya Das, clear. Bidushmita, clear, ma'am. Nitya Modi, got it. Anshita, clear. Nibha Chaudhary, crystal clear. Yes, 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 definitely we will have Menti. The final result, right? Anything here you want me to explain again? See, you have this triangle, right? Let's consider a triangle over here. What does converse of midpoint theorem says? You have a triangle, right? We have this triangle ABC over here. Let's plot the midpoint on any one side. Let's suppose this point is M. Now let's take any random line of any length. You place it here on the midpoint such that it is intersecting this. Now just move it such that it is parallel to the third side. It's parallel to the other side, which is AB. So once it is parallel to this, you will see that it is bisecting the other side, right? Yes. All right. Clear? Great. Now let's try out a few questions based on the midpoint theorem. So here we have a question. ABC is a triangle right angled at C. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Show that CM is equal to MB is equals to half of AB. So much information is given in the question. So when you come across such questions, first of all, read it slowly. Draw the figure first. We are talking about a right angle triangle ABC. So we'll go step by step. First, let's draw a right angle triangle ABC, right angle at C. Right? Here is the 90-degree angle. A line through the midpoint M of hypotenuse AB. AB is the hypotenuse, right? So from here, midpoint of hypotenuse AB, this is the midpoint M of hypotenuse AB. A line through AB, this is the random line that we have here, parallel to BC. So let's place it here. This line has to be parallel to BC. So this line has to pass through M. So it is parallel to BC. We move it like this, right? And it is intersecting AC at D. You see it is intersecting this AC at point D over here, right? So that's how you draw the figure based on the given information. Yes, Deepak, trick kaam aayi, step by step you go, right? Great. Hypotenuse is basically the side which is opposite to the 90-degree angle in a right angle triangle. That's the longest side of the right angle triangle. Yes. Okay. Now we need to show that this CM is equal to MA is equals to half AB. MA is here, AB is here. Where is CM? Now to show that, first let's join CM, right? So we have joined CM now. So what is the given information we have? We have that BCA is 90 degree because question says it is right angled at D, right? Question says it is parallel to BC. This line is parallel to BC. So this MD and BC are going to be parallel. You can see the highlighted lines in green. Yes, Bhavna Solanki. We have a right angle triangle over here. I'm explaining it one more time for the people who haven't understood this. We have a right angle triangle over here. It is right angled at C. A line through the midpoint M of hypotenuse. What is the hypotenuse here? That's AB. Right? This is the midpoint M. So a line through this parallel to BC. This is BC here. A line through M should be parallel to BC. Since it is parallel to BC, it has to be straight, right? Intersecting this AC at D. It is intersecting here, right? Chota Bheem. Trick is this, step by step. Literal translation, word by word translation karo aap statement ki. Spasht, yes, great. Yes, it's not a difficult question though. Nibha, it's not necessary that you have to draw a dotted line for CM only. You can draw a solid line also. That will also work. Okay. So now we draw this line parallel to this. It is intersecting at this point D. So I hope the figure is clear to everyone. Yes? Quickly, just write in the comment section so that I can move ahead. Nibha Chaudhary, okay ma'am. Pritika Banerjee, yes, simple one. Doubts clarifying by Vaishnavi, yes. Bhavna Solanki, yes, ma'am. KTB, vlogs and recipes, easy. Great. Let's move ahead. So what is the given information? BCA is 90 degree since it is right angle at C. Okay, this is 90 degree. This MD is parallel to BC. We all know why it is parallel, right? This was given in the question already. Now, this angle will also be 90 degrees, right? Because these lines are parallel, you see. This is the transversal, right? So anyways, the corresponding angles are formed. So this will also be 90 degrees. MDA and MDC both are 90 degree. From linear pair also they will be 90. Deepak, solved it. Wow, great. Okay, now what we can do is we have to show that CM is equals to half of AB. To prove this, I'll be using the midpoint theorem. So from midpoint theorem, we know one thing, that this CD over here is going to be half of AC, right? This is already given in the question. Why? Because it is drawn through the midpoint M over here, right? So once you use the congruency also, you can say that this will be half of AC. So CD and DA over here are equal. So this triangle MDA and MDC, they both would be congruent using the SAS congruency criteria. Yes. So once they are equal, I can say that the CM is equals to AM, right? CM and AM are equal. Why? CPCT, corresponding parts of congruent triangles, are equal, and that AM is already equals to half of AB because M was the midpoint of AB. So CM is also equals to half of AB. Yes. All right. Yes, Saran, congruency you will have to prove for MDC and MDA, right? Papiya Das, yes, SAS. All right. Purva Deshmukh, yes, we have Menti today. So using this midpoint theorem, you can say that because see, this AB and CD, these are the two line segments of this triangle, right? And these are the two midpoints. So a line was drawn through this midpoint, right? And it is parallel to this. So what do we learn in the midpoint theorem? It will be half of it as well, right? This is half of it. So MD is half of BC also, right? So here it is drawn to the midpoint. This will be equal. CD is half of AC. CD and DA are equal. So using the congruency criteria, you can prove it. Yes. All right. Clear. Great. So this was the last question of today's session, and as I said, once the session ends, we are going to have the live quiz. So all of you know how to join the live quiz, right? You have to go to menti.com for that, and it will ask for a code. Use this code 90287576. Yes. Quickly see if you have two devices, that would be great. On one device, through one device, you can join the quiz, and on the other device, you can watch the session which is going on. Or if you have only one device, you can use the option of split screen. Yes, Nibha, Menti time. Yes, Ayush, I'm waiting. Don't worry. I'm waiting. Quickly join the quiz and write in the comments section that you have joined so that we can start the session. D. Deepak, literal translation ki thi. Yes, this always works. Okay. Yes. Quickly join it and write in the comment section that you have joined. Human being joined. Papiya Das, Dev Goyal, Ankush Kumar, Vipul Pandit, Vidushmita joined. Yes, DIY Crafts, Arya and Nidhi joined. Yes, doubts clarifying by Vaishnavi, join ma'am. Nitya Modi has joined, Akriti has joined, Sanya, Anshita, Arathi Dilip, yes, Vidit Kalra. See, I would suggest you, while you are joining the quiz, please watch the session also because I'll be explaining the answers as well. All right, all right. All right, quickly. Ayush Biswas. Rachit Yadav has joined. Yashasvi has joined. Sonali Day. Kanishk. Purva Deshmukh, split screen. Good. Yes. Lakshmi Jangir. Yes, yes, Lakshmi, you can join, definitely. Anything here? All right. Yes. Vipul Pandit, you have PC, no worries. Yeah. Yes. Yes, Yashasvi will start in a few seconds. Let's wait for others also to join. We'll wait for another few seconds so that everybody can join. I can see a lot of people have joined here. Lakshmi, thank you. Yes, Deepak, take your time. I'm waiting. Don't worry. Bhavna Solanki has joined. Vipul, the laughing cat. Okay, I can see that. Yes. Yes, Bishal has joined. Nibha. Rachit Yadav, rugby ball. Oh yeah, I can see that. DIY Crafts, donut. T. Deepak, screen splitted. Great. Yes, Sonali, now I know your name is special. Yes, I've read that. Papiya Das, yours is banana. Lakshmi, yes, it's full of animals and emojis, but they are so cute, yeah? All right, all right. So I think that a lot of people have joined. Let's start it. All right, so here we go. And this is our first question. The diagonals of dash bisect each other. And you have 45 seconds to answer this quickly. Trapezium, rectangle, quiet or none. A very simple one. See, I would say that if you have watched both the sessions of Quadrilaterals, part 1 and part 2, the concept capsule, you'll be able to answer it easily. Purva has already answered. Vishal has answered. Yes. Anshita, yes, I can see a few answers over here. Yes, Ayush, definitely I'll show you the leaderboard. Don't worry. I can see answers have started coming up. DIY crafts answered. Yes. Okay, okay. Now let's see how many of you have given the right answer. Time is up. Maximum students have given the correct answer, which is rectangle. Some are saying it's trapezium, some are saying kite, some say it's none. This was a very simple one. All you need to know is the properties thoroughly, right? See, I would suggest that for such geometry chapters, it's very important that properties should be crystal clear in your mind. Let's take a look at the solution. The diagonals of a parallelogram bisect each other. Then we can say that the rectangle is a parallelogram. Yes, anything here? Yours was correct. Nibha Chaudhary. Kanishk, you answered in hurry. Why do you need to rush with it? It was a very simple question. There was no solving. As I said, all you need to know is the properties. All right, all right. So those who haven't answered it correctly, I would suggest that go through the properties one more time. Watch the part 1 as well of the concept capsule. All right, let's take a look at the next question. So we have question number 2 here. Yes, Sanya, you got correct. Great. So in figure, D is the midpoint of AB and DE is parallel to BC. Then AE is equals to what? You have a figure here. 45 seconds you have to answer this. Yes, Bhavna Solanki, you got wrong. Why? It was a very simple one, right? Properties को अच्छे से आप practice करो एक बारी. Yes. It's based on midpoint theorem that we just learned. Sanya, 5.17 seconds. Wow. I can see the answers have started coming up. But mixed answers I can see over here. All right. Yashasvi has answered. Anshita has answered. Amrendra, Purva Deshmukh, Sahil, Shilpi. Time is up. Mixed answers are here, but some are saying it's EC, some says it's AD. Few students are saying it's DB and some are saying it's BC also. Mixed answers. Why? Okay, let's see the correct solution. So AD and DB is equal and DE was parallel to BC, right? So midpoint theorems, according to that, E would be the midpoint of AC, right? So that means if E is the midpoint of AC, we can say that A is equal to AC. A is equal to EC. Nitya Modi, you gave the correct one. Yes. Suyansh, galti se galti ho gayi. All right, all right. Let's take a look at the next question now. So here we have our question number 3. So ABCD is a trapezium such that AB is parallel to CD, angle A is 60 degree and angle C is 100 degrees. The value of angle B plus twice angle D is. 4 angles you can see here, right? I would suggest draw a figure first to understand this. Yes. Soumya, you gave the correct answer. Bhavna also gave correct. Yes. I can see answers have started coming up. Great, good speed. Wow. Yes, study changes life. Thank you, Vaishnavi. All right, all right. Just few more seconds to go. All right, so time is up. Okay. Oh my God, mixed answers. किसी को A लग रहा है, B लग रहा है, C लग रहा है, D लग रहा है. Papiya Das, easy question but time taking? No, it wasn't time consuming. According to 45 seconds recording, this was a very simple question. कुछ नहीं था इसमें ऐसा. Okay, let's check the solution. And let's see where actually you got wrong. AB is parallel to CD, angle A is 60 degree, angle C is 100 degrees. Please make the figure for such questions. So angle B plus angle C would be 180 degree in that case, right? So from here I can get the value of angle B, that's going to be 80 degrees. So angle A plus angle D is also 180 degrees since it's a trapezium, right? So co-interior angles are formed here. So angle D would be 180 degree minus 60, that's 120 degree. So angle B plus twice angle D, just substitute the values, you get 320 degrees. Papyadas, you also got wrong. Yeah? Anything here? Time consuming but got right. Nibha, galti se mistake ho gayi. See, you don't need to rush when you come across such questions. Whatever information is given in the question, first make the figure. Write down the given information, right? You don't have to write everything properly because it's an MCQ question, right? Alright, let's take a look at the next question, but before that, let me show you the leaderboard. Yes, okay. Alright. So rainbow, the top we have Rainbow, Ashima, Guru Rajesh, Saransh, Priyanshu Ranjan, Anushka, anything here, Shaurya, Siona, Sanya. And I can see that initially from Rainbow to Ashima, there is a big margin, there is a big gap. After that, the gap is very less. And then at the end also. But still, you did a great job. Wow. Nibha, 16th place. Not bad. Papiya Das, you took B as 60 and the D as 100. That's okay. See, that's why I told you. Don't need to rush with the questions. 11th place. That's good. That's okay. Ayush, 18th. Alright. Great. Now, let's move ahead. Let's take a look at the next question. So, we have question number 4 now. Alright, so a dash can be formed by joining the midpoints of all the sides of the rectangle. 45 seconds you have. Shreya, you got 2 of them wrong. So out of 3 you got 2 wrong. See, practice well. Maths is a subject that you will learn only with practice. Ankush, 44th place. Yes. Janvi, 28th. Anshita, 21st place. That's okay. Okay, some people have already given the answer. But again, mixed answers are there. Ankush, 4.154 seconds. That's fine. That's good. Alright, so your time is up. Let's check what the correct answer is. Oh my god. Some are saying it's rhombus, some are saying it's parallelogram. I would say, almost equal number of students are there who are in favor of rhombus and parallelogram. Still, some are saying square and rectangle also. Let's see what the correct solution is. So we were talking about this rectangle, right? And we had the midpoints here. We joined them. So according to midpoint theorem, we know that in this triangle ACD, S and R are the midpoints. So SR is parallel to AC also. And so SR would be half of AC. In triangle ABC, PQ is parallel to AC and it's half of that also. So PQ is parallel to SR. It is equal to SR also. That is a property of parallelogram. So in this triangle ASP and BQP, we can prove them congruent by SAS rule. So we can say that SP and PQ would be equal. Similarly, SR and QR would be equal. So we can call this PQR as a parallelogram. Sanya, again wrong. Aditi, first time giving this type of quiz. Really amazing. Great. Nitya Modi got it correct. Bipul, right again. Sanya going from 10th to 50th. That's okay. Don't worry. Alright. So this was the proof for this question. Okay, let's move ahead. Let's take a look at the question number 5 now. Alright. So this says that which of the following is not true. Square is rectangle, rectangle is parallelogram, rhombus is a parallelogram, trapezium is a parallelogram. Quickly. Nitya, you are enjoying this quiz also. Wow, great. Ayush, wrong again. Anything here got wrong this time? See, don't rush with these questions. These are very simple questions, I would say. So properties you need to know. So easy. Yes. It is actually easy. Answers I can see. Some Some are saying A, some are saying B, D. Ankush, 5.809 seconds. Not bad. Okay, time is up. Now let's see what the correct solution is. Some students are saying trapezium is a parallelogram. Some are saying square is rectangle. Few are saying rectangle is parallelogram and few are saying rhombus is a parallelogram. Okay. बहुत confidence है, गलत नहीं हो सकता. Okay. Let's see the solution. So you can see this Venn diagram over here, right? Rhombus, rectangle and square, they are all parallelograms, right? And trapezium and quad, they are considered as quadrilaterals. I think when we were doing the concept capsule also, somebody asked this question, what all are actually included in the parallelograms, right? You can see this Venn diagram now. The same Venn diagram we have explained in the part 1 of quadrilaterals also. Yes. So many students are saying got correct. Wow. Great. Let's move ahead. Let's take a look at question number 6 now. Yes, if perimeter of triangle ABC is 36 centimeter and PQR are the midpoints of BC, AC and AB respectively, find the perimeter of PQR. 4 options you have, quickly answer this. Somebody just asked, Ayush Biswas, square is a rectangle. Yes, you can call a square a rectangle, but you cannot call a rectangle a square, right? Yes, D. Deepak, got correct. Wow. Okay, wow, Raghav, you are too fast, I must say. Yes. Quickly. Purva has answered it. Dev Goyal. Yes. Deepak, 11 seconds. Wow, good speed. Okay, mixed answers again. Some are saying 9 centimeters, some are saying 18, 20 or 36. But still, maximum students, I would say they are saying it's 18 centimeter. Let's check the solution. And you can check where you got wrong actually. So PQ is half of AB, QR is half of BC and PR is half of AC, right? Using the midpoint theorem. So perimeter of ABC is what? Sum of all the sides. That's PQ plus, that's AB plus BC plus AC. And AB can be written as half of, perimeter of PQR is PQ plus QR plus PR. This PQ can be written as half of AB, QR can be written as half of BC, PR can be written as half of AC. We are just using the given information in the question. And then we take half common, we add all them up, AB plus BC plus AC, that's 36 centimeter. We cancel them out, we get 18 centimeter. A very good, very interesting question, I would say. Vaishnavi, misclick. Oh. V. Deepak, 11 seconds, it is correct. Wow. Amrendra, yes, 18 centimeter. Ayush, 3 by 6. No, it's not 3 by 6. From where are you getting 3 by 6? Okay, you are saying 3 questions correct out of 6. Okay. D. Deepak, correct IRA. Yes? Good. Okay, so this was the last question of today's Menti. Now let's take a look at the leaderboard this time. Who is actually leading it? Okay. And again, rainbow. And then that's 25603. Then Ashima, then Priyanshu, Guru Raj. All right, great. Wow, amazing. Wow. Okay, so that was the last question of today's Menti session. But this is not the end because we have got many more sessions for you from every Monday to Friday to make you exam ready. So let me give you a glimpse of the upcoming session. So we have our next practice session on quadrilaterals, which is on January 28th. That is Friday and timing is 5 p.m. And if you want to have access to more such great content, then please click on the link in the description below and you can get all your doubts clarified instantly during the class. So I'll see you soon in the next session. Until then, be curious, keep learning and take care. Thank you.